Our objective for the lesson today is to be able to use multiplication or division to solve an inequality. Just like when we solved equations, we're going to use multiplication and division properties. But in this case, in the case of inequalities, the application of those properties are a little bit different. All right? Well, case number one. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. For example, if you start with the inequality negative 4 is less than 6, right? We all know that negative numbers are less than positive numbers. And you take that inequality and you multiply both sides of that inequality by a positive number, right? Let's say 2. You get the following inequality. Negative 8 is less than 12, right? And that is a true statement. So when we multiply both sides of an inequality by a positive number, the inequality remains true. Let's see if it works for division, right? Let's start with the inequality. 4 is greater than negative 6, right? We know positive numbers are greater than negative numbers. If we divide both sides of that inequality by a positive number, let's say in this case positive 2, we get the following inequality. 2 is going to be greater than negative 3, right? Which is also true. So in every case, if we divide or multiply both sides of an inequality by a positive number, the inequality remains true. And these properties are also true for less than or equal to and greater than or equal to. All right, so let's see how that's going to work. So if I start with the following inequality, right, which says that a number divided by 5 is less than or equal to negative 3, we want to find the solution set for that inequality. Well, I see that the variable is being divided by 5, so your first step here, all right, well, let's recopy it first so it make the math a little bit cleaner. So we do a number divided by 5 is less than or equal to negative 3. All right, and we see the division. The opposite of division is multiplication. So we want to multiply both sides of the inequality by a positive number. So we're using that multiplication property of inequality. On the left side of the inequality, 5 in the numerator is going to cancel 5 in the denominator, and we're left with x. The inequality stays the same, and then we multiply. On the right side of the inequality, negative 3 times 5 is negative 15. Right? So the solution of the inequality, x is less than or equal to negative 15. When we're graphing the solutions, right, on a number line, we want to locate 0 on the number line, and negative 15 is going to be to the left of 0. We have a closed circle, so I want to fill in that circle, and the solutions go to the left. Let's check a value to make sure that it's true. So I want a value that's less than negative 15, right? Let's try negative 20, see if it's true. So if I replace x with negative 20, right, because the negative 20 would be in my solution set over here somewhere, negative 20 divided by 5 would be negative 4. Is negative 4 less than or equal to negative 3? Right? Yes, it is. So I feel comfortable that the solution set is correct. All right? So if we're looking at each one of these examples, all right, start with the first one. I see division. Well, let's recopy that, right? That should be a number n divided by 3 is less than 1. We see division. The inverse operation would be multiplication. When we show multiplication, I like to use parentheses on both sides of the equation, or both sides of the inequality. 3 in the numerator is going to cancel 3 in the denominator, and we're left with n is less than 1 times 3 is 3. We graph that solution. Here's 0. Here's 3. It's an open circle at 3, and the solutions go to the left. 0 is within the solution set, so let's try 0 and see if it makes the inequality true. So if I replace n with 0, 0 divided by 3 is 0. Is 0 less than 1? Yes, it is. So that inequality looks good, and that solution set looks correct. Let's try the next one. Right, I see division. The inverse of division is multiplication, so we will multiply both sides of that inequality by 10. All right, let's show that. The 10 in the numerator is going to cancel the 10 in the denominator. 10 times negative 0.5, that's going to be negative 5, is less than or equal to m, right? One-step inequality. That's a reversed inequality. So when we go to graph that, we have to be a little bit more careful. Right, we have 0, we have negative 5. It's a closed circle at negative 5. But because it's a reversed inequality where the value comes first and the variable's on the right side of the inequality, the solution should be in the opposite direction of which the arrow in the inequality is pointing. But let's check it to be sure. So let's try something that's divisible by 10, right? That's on the right side of the inequality, right? So let's try that. So I'm going to try 10, right? Because 10 would be over here in the solution set. 10 divided by 10 is 1. Is negative 1/2 less than or equal to 1? Yes, it is. So that looks like that is correct, right? Let me circle my solutions here. All right. Let's look at our third one. We have 2/3 times a value p. The opposite would be to divide by 2/3, right, on both sides of the inequality. On the right side, they cancel and become 1. But on the left side, we're going to have negative 3 divided by 2/3. When we reciprocate and multiply, that becomes negative 3 times, right, 3 over 2. And that's got to be greater than p. Negative 3 times 3 is going to be negative 9. So we wind up with negative 9 over 2 is greater than p. Once again, we have a reversed inequality, right? So let's draw the graph there. We have 0, negative 9 over 2. It's going to be over here, right? Because that's negative what? 4.5. It's an open circle. Arrow's pointing to the right, but because it's a reverse inequality, solutions have to go the other way. Now I want to choose a value that's less than negative 4.5 and see if it works. So I want to pick something that when I multiply by 2/3, I'm going to get a whole number. So what's less than negative 4.5? That's divisible by 3. So let's try negative 6. So negative 6 would be in my solution set over here. So let's see if negative 6 works here. 2/3 times negative 6 is going to be negative 4. Is negative 3 greater than negative 4? Yes, it is. So I've checked, and my solution is correct. All right. If we're solving the inequality using division, right, same idea. We want to use the division property. So we want to do the inverse operation. So we're going to divide both sides by positive 6. On the left side, they cancel. We're left with x is going to be greater than negative 18 divided by 6 is negative 3. When we go to graphing the solution, 0, negative 3 is going to be to the left of 0. It's going to be an open circle at negative 3, right? My solutions are going to be to the right because x has to be greater than negative 3. Well, let's try something that's in the solution set. 0 is in my solution set. So let's replace x with 0, see if we get a true statement. 6 times 0 is 0. Is 0 greater than negative 18? Yes, it is. So that looks like that's going to work. All right, let's try these three down here. We see multiplication. The inverse would be division. Divide both sides by positive 4. They cancel. So we wind up with b is going to be greater than or equal to 2 over 4 is going to simplify to 1/2. Right? We graph that solution. Here's 0. 1/2 is going to be to the right of 0 on the number line. That's going to be a closed circle because it's greater than or equal to. Arrow's going to go to the right. So if we're checking our solution set, it looks like 1 would be within the solution set because 1 is to the right of 1/2. So if I replace b with 1, 4 times 1, is 4 times 1 greater than or equal to 2? Yes, it is. All right. Next one, we see multiplication. We use the inverse operation. We divide. We wind up with k is less than or equal to. Looks like that's going to be negative 2 when we divide negative 24 by 12. If we're graphing that solution, right, I locate 0. Negative 2 is going to be to the left of 0 on the number line. It's going to be a closed circle, and my solutions go to the left. I want to check it, so let me check something that's to the left of negative 2. Let's try negative 3. 12 times negative 3 is negative 36. Is negative 36 less than or equal to negative 24? Yes, it is. All right, this last one, we want to divide both sides of the inequality by 2.5 because we're using the inverse operations. Right, they cancel. All right, so we're left with negative 15 divided by 2.5. That should be negative 6. Right, negative 6 is going to be less than q. It's a reversed inequality, so let's be careful when we graph it. Right, got to circle my solutions here. So we have 0. Negative 6 is going to be to the left of 0. It's an open circle, but because it's a reversed inequality, my solution should go to the right. I see zeros in my solution set, so let's try 0. 2.5 times 0 is 0. Is negative 15 less than 0? Yes, it is. All right. So these last several problems show that when you multiply or divide both sides of an inequality by a positive number, right, the inequality remains true, and it allows us to find solutions to one-step inequalities. Right. But there is another scenario, right, and that's going to be case 2 here. Right. And case 2 says that when you multiply or divide each side of the inequality by a negative number, the direction of the inequality symbol must be reversed for the inequality to remain true. Well, what are we talking about there? Well, let's check it out and see. Right, let's pick a number to divide negative 4 by. Let's say we pick what? Let's see, or let's multiply. So let's multiply both sides by some negative number. Let's pick negative 1. Multiply by negative 1 here, multiply by negative 1 here. Negative times negative is positive, so I get 4 is less than 6 times negative 1 is negative 6. But I say, wait a second, 4 is not less than negative 6. Right? That is not true. In order to make that inequality true, we actually have to reverse that inequality symbol. And when we reverse that inequality symbol, now we get a solution that is true. Right? 4 is greater than negative 6. So in this instance, and every instance, when we multiply both sides of an inequality by a negative number, we have to reverse the inequality symbol to keep the inequality true. Well, let's see if it's the same for division. So we have the inequality, 4 is greater than negative 6. Let's divide both sides by a negative number. Let's divide by negative 2. Let's see what happens. 4 divided by negative 2 is negative 2. Greater than, negative divided by negative is positive, and we get the following. Negative 2 is greater than 3. And we say, wait a second, that is not true. We'd have to reverse the inequality, right, to make that true. All right, so we see that when we multiply both sides of an inequality by a negative number, we have to reverse the inequality to make it true, and the same is true for division. When we divide both sides of an inequality by a negative number, we have to reverse the inequality symbol to make it true. And down here it does simply says that these properties are also true for less than or equal to and greater than or equal to. So let's jump into some examples. All right, let's start with this inequality. Negative 3 over 2 times the number n is less than or equal to 6. When you look at the inequality and you see the negative coefficient of the variable, that's when you have to raise your eyebrows a second and say, wait a second, I'm probably going to have to reverse my inequality symbol because I have a negative coefficient for my variable. But anyway, what do we have to do here? Well, we have to divide both sides of the inequality by negative 3 over 2. They're going to cancel. So now we have n, I reverse the inequality, is greater than or equal to, well, what's 6 divided by negative 3 over 2? Well, that's going to be 6 times negative 2/3. What's 6 times negative 2/3? 6 times 2 is 12. 12 divided by 3 is 4. So that's going to be negative 4. But I want to check that, right? Got to make sure that that's correct. So let's see. If we graph that, and it has to be greater than negative 4, we have 0. We have negative 4, right? It's a closed circle because it is greater than or equal to negative 4. And my arrow is going to go to the right. Well, if I check it, right, let's check it with 0 because 0 seems to be part of my solution set. If I replace n with 0, negative 3 halves times 0 is 0. Is 0 less than or equal to 6? Yes, it is. So by reversing my inequality symbol after we divided by -3/2, right, it kept the inequality true. Right? So let's try these examples here. So for number 7, first let's recopy it. So for problem 7, we have a number divided by -3 is greater than -4. We see that the variable is being divided by -3, so the inverse operation would be to multiply both sides of that inequality by -3. On the left side of the inequality, they cancel out, so we get x has to be less than negative times negative is positive, 4 times 3 is 12. There's my solution. All right. It says to graph it, so let's graph number 7. Come down here. All right, we have 0. 12 is going to be to the right of 0. It's going to be an open circle. Solutions go to the left. Right, so let's check using 0. It's in our solution set. All right, and when I check using 0, all right, we have 0 divided by -3 is 0. Is 0 greater than -4? Yes, it is. So that seems like that's going to work. Let's try problem 8. 5/10 is less than or equal to the opposite of a number y divided by 2. We see the division. Now, the inverse of division is multiplication, but if I want to get rid of that negative sign and the 2 in the denominator, I'm going to have to multiply both sides of that inequality by -2. The -2 in the numerator cancels that -2 in the denominator. All right, so we're left with y. Oops, let's undo that. Oop. But because I multiply both sides of the inequality by the negative number, we have to reverse the inequality to keep it true. So we're left with y over here, and what's -2 times 0.5? That should be -1. It is a reversed inequality, so when I go to graph it, let's just be careful. We have 0, -1, -1 is to the left of 0. It's a closed circle, but my arrow is going to go in the opposite direction here because it is a reversed inequality. Well, let's check it. Right? So I need a value in the solution set that's less than or equal to -1. Hey, let's try -1, right? Because -1 is equal to -1. Yeah, so let's try -1. Why not? So if I replace y with -1, negative times negative is positive, we get 1/2 here. Is 0.5 or is 5/10 less than or equal to 1/2? The answer is yes. All right? All right, let's recopy 9 over here. All right, question number 9. We have -12 greater than or equal to 6/5 m. We see that we're multiplying the variable by 6/5. Right, so the inverse of multiplying by 6/5 is to divide by 6/5. Divide by 6/5 on both sides of the inequality. Now, here's right where students get tricked, right? Because they see the negative here. But did we multiply or divide by a negative number, right? And the answer to that is no, right? We divided by a positive number. So we are not reversing the inequality here, right? The inequality is going to stay the same. So what is -12 divided by 6/5? Well, that's going to be -12 times 5/6. And what is -12 times 5/6? That should be -10. So we wind up with -10 is greater than or equal to m. All right, let's check that solution. So we have 0. We have -10. It's going to be a closed circle at -10. All right, but because it's a reversed inequality, right, it's reversed because the variable's on the right side, my solution should go in the opposite direction of my inequality symbol. Let's check something that's less than -10 here. So I don't know, let's try something that would work out nicely. So 6/5, something that's divisible by 5. Let's try -20. All right, well, what's 6 times -20? Well, 6 times -20, let's see, 6 times -20 would be -120, -120 divided by well, let's say, um, yeah, well, let's try, it's less than or equal to or greater than or equal, let's try negative 10. But we're going to see a problem here, right? Because if I replace with negative 10, 6 times negative 10 is negative 60. Negative 60 divided by 5 should be negative 12. Is negative 12 greater than or equal to negative 12? Right, yes it is. So that should work. But let's try negative 20. Right, negative 20, if I replace m with negative 20, which is in our solution set, right, let's try negative 20. Right, negative 20, that'd be negative 24, right, because that would be 6 times negative 20, negative 120. Negative 120 divided by 5 would be negative 24 over here. This is negative 12 greater than or equal to negative 24. Yes, it is. Right, so that graph does work. Right, always want to check it if you can. Don't go crazy checking, but we should always try at least to check. Problem 10. Negative 2/5 times h is less than or equal to negative 8. Right away I see a negative coefficient for h, so that should, kind of alert us to let us know that we will have to reverse the inequality symbol at some point. To get h by itself, we have to divide both sides of the inequality by negative 2/5. On the left side they cancel. H then has to be greater than or equal to, right, because we reverse the inequality because we divided both sides by a negative value. And then what is negative 8 divided by negative 2/5? Well, let's do that over here. Negative 8 times negative 5 over 2. All right, we multiply, reciprocate and multiply. That becomes positive 40. Positive 40 divided by 2 is going to be positive 20. All right, let's check the solution here. We have 0. We have 20 is to the right of 0. Closed circle, right, arrow's going to go to the right. So I'm going to check something that's, I don't know, let's try 40, right, because 40 is in our solution set. Well, what is 2/5 of 40? 2 times 40 is 80. 80 divided by 5 is 16. So this is negative 16. Is negative 16 less than or equal to negative 8? Yes, it is. So we check our solutions. We see that our solutions are correct, and that's how we want to go about doing it. All right. So to finish this up, we want to solve the inequalities using division. Right, I see division here, so I'm going to divide both sides by a negative number, right, negative 3, so we know we're going to have to reverse the inequality symbol. Negative divided by negative is positive, so we're left with z is going to be less than, well, what's 4.5 divided by 3? That's going to be 1.5, and negative divided by negative is positive, so we have z is going to be less than 1.5. Let's graph our solution. Right, so we're going to have 0, going to have 1.5. It's an open circle. Arrow goes to the left here. Let me try 0, right, because 0 is in the solution set. Negative 3 times 0 is 0. Is 0 greater than negative 4.5? Yes, it is, right? So just keep checking those solutions, right? All right, we have our last 4 problems here, right? So let's play around with these a bit. All right, problem number 11, let me recopy it. Number 11, we have negative 5 times the number z is less than 35. I see that negative coefficient, so I know I'm going to have to reverse the inequality. Divide both sides by negative 5, they cancel. Z has to be now greater than 35 divided by negative 5 is negative 7. Let's check it. Right, so we're going to have 0. We're going to have negative 7 is to the left of 0. Open circle. Arrow goes to the right. 0 is in my solution set. So I'm going to replace z with 0. See if I get a true statement. Negative 5 times 0 is 0. 0 is less than 35. Problem 12. Negative 2 times a number is greater than negative 9. Once again, I see the negative coefficient, so I know I'm going to have to reverse the inequality symbol. Divide both sides by negative 2. They cancel on the left side. We get a has to be less than. Negative divided by negative is positive, right? 9 over 2. That's 4.5. Let's graph the solutions. Right, we have 0. 4.5 is to the right of 0 on the number line. It's an open circle, arrow going to the left. I'm going to check with 0 because it's in my solution set. And I always like checking with 0 because it's easy, right? The math is easy. So negative 2 times 0 is 0. Is 0 greater than negative 9? Yes, it is. All right, so let's try problem 13. All right, let's copy. Problem 13 is negative 1.5 is less than 3 times the number n. Right, and this is one of the problems where students tend to make mistakes because they see that negative here and they think that they're dividing by a negative number. But no, we have to focus on the coefficient of n. And the coefficient here is positive. So we're dividing both sides by a positive integer. We are not reversing the inequality symbol here. Negative 1.5 times 3 is going to be negative 5/10, and that's going to be less than n. If we're graphing the inequality, I see that the variable's on the right, so it is a reversed inequality. Right, we're going to have 0. We're going to have negative 0.5. Right, let me make that a little better. Negative 0.5 is to the left of 0. It's going to be an open circle, and because it's a reversed inequality, arrow's going to go in the opposite direction of the inequality symbol. Let's check it using 0 because 0's in that solution set. 3 times 0 is 0. Is negative 1.5 less than 0? Yes, it is. All right, and the last problem of our lesson here, question 14, we have negative 4.2 is going to be greater than or equal to the negative 7/10 w. I see the negative coefficient, so I'm going to have to reverse my inequality symbol. We're going to divide by that negative coefficient on both sides of the inequality. All right, on the left or on the right side, they cancel. All right, so we're going to be left with w over here, but we have to reverse the inequality symbol because we just divided by a negative number. What is negative 4.2 divided by negative 0.7? All right, 7 times, that's going to be what? 6 times. So that's going to be positive 6 because negative divided by negative is positive, and 7 goes into 42 6 times. All right, so there's our solution. Let's graph it and see. All right, and check it. So we're going to have 0. 6 is to the right of 0. Should be a closed circle, right, at 6. Closed circle. And which way? Because it's a reversed inequality, solutions are going to go in the opposite direction. I check the math, check something that's in the solution set. So let's try 10, right? Because 7/10 of 10 is easy to do. So let's replace w with 10. Negative 7/10 of 10, that's going to be negative 7 over here. Is negative 4.2 greater than or equal to negative 7? Yes, it is. So hopefully we learned the importance of reversing the inequalities when we're multiplying or dividing by a negative number. All right, I hope that that's been helpful, and have a good evening.